Hello everybody, welcome once again. Here is Rajesh sir YouTube channel. Now today Rajesh sir will teach you the gravitations in physics. Gravitations we are discussing about the Kepler's law. Kepler's first law we have discussed here. Now we will discuss about the second law, third law. The second law that is associated with the area, and the third law which is associated with the associated with time periods and constant values and relations between the force and the time periods and it's a force in relations between a force and a time period. How we will get the force on the basis of this some physical properties we will discuss about the Kepler's second and the third law. First we will discuss here the Kepler's second law. Here is the physics, okay. Gravitation, Kepler's second law. Kepler's second law. Kepler's second law. Kepler's second law. It states that an imaginary lines. It states that an imaginary line, imaginary lines, imaginary lines from the sun to the planet swipe out, sweep out, sweep out, sweep out, sweep out equal area, sweep out equals area in equals interval of times, intervals of times, in equal interval of times. Thus if the time of thus if a time of suppose that if a time of the if the time of the planets okay equal areas and equal interval terms, thus if the time suppose that here is the figure, elliptical path. Here is the figure, okay. uh, yes, this is figure, and suppose that here is the sun, here is the suns, and suppose that we have drawn here a structures of uh, a line drawn, okay, from A to B and B to C and C to D. So this is the suppose that 1 month, it is 1 month, and here is also a 1 month, 1 month A B C D, and this points are in O, and it's a sun. Here is the A B C D is a planets, two planets is given here, and suppose that two planets given here, thus we will discuss about it's thus the if the time of the traveling of the planet from A, okay, if the time of the traveling of the planet from A to B, if the time of the traveling of the planet from A to B and from A to B and C to D is same then same, between C to D is a same, then the area of, okay, according to questions, as the question says, so statement say that then the area of area what will be AOB is equals to the area of AOB and ABCOD. COD. Okay, this is the COD. This is the Kepler's law. We have discussed here Kepler's law. Now we will discuss about this as here is the Kepler's second law. This is state is, and as Kepler's third law we will discuss here Kepler's third law, second law, Kepler's third law. What does Kepler's third law say? That Kepler's third law, it states that the it of the Kepler's third law. What does that say? It states that the cube of the mean distance of it is state that the cube of mean distance mean distance means that if the we are talking about the planets, mean distance of planet from the sun is mean distance of planet from the sun is directly proportional to its time periods, and directly proportional to its time periods of its orbital periods, and to the square of the orbital period t, square of the orbital period capital T. So the orbital period capital C. So we will know that. So thus we can write here. So I can write here. Thus, as we notice, according to questions, RQ, it's stated that RQ is proportional to capital T, and it's also cube is also time period square. So we can write here RQ is equal to RQ is equal to K T square. Okay, then we further write here K is equal to RQ by capital T. Okay, square. These are the K, where K is Kepler's, where K is equal to Kepler's constant, and R is radius, and T is time period. Okay, T is time periods. So we can say, so as we know that F is equal to mv square by R, as we know that F is equal to mv square by R. Here we already know about the according to the it's according to the force that applied by the Newton's. So because Kepler does not explain and give the theory, so Newton's have stated it's with the help of its force, because Newton's have given a gravitational gravity of the earth and gravitational forces. So on the basis of this, he has given that K is equal to F by R 1. So equations 1, and suppose that T is equal to 2 pi R by B, as we know that. So T is equal to 2 pi R by B. 2 pi R by V. It is seconds. Suppose that it's a second, 2 pi R by V. So V is equal to 2 pi R by T. So V is equal to 2 pi R by B is equal to T will be divided. So substitute this value in equation for us. Substituting. Oh, it's not watching. Sorry. So we will take here another place. Here is the place. So T is equal to, as we know that, so K is equal to K. I have given you K is always be equal to the RQ by T square, and F is always we know that MV v square by r, mv square by r. First equations, and as we know that capital T time period is equal to 2 pi r by v, and v is equal to 2 pi r by, here is T substitute, it's a second, seconds, substitute this value, substitute this value in equation first. We will get here in equation first. Suppose that we have substituted this value in equation first, we will write here v square, substitute this value, f is equal to m by r, f is equal to m by r, in brackets we will get here 2 pi r by t, r by t whole square we get here. And as we know that 2 pi r by say r is always v, 2 pi r by v square with 2 pi square m v by t is equal to 4 pi square m v by t. So m r by m r v by t, r v is r is equal to, as we know r is equal to kt squares, or r is equal to kt squares. So we will also substituting this value in another equations, we will get here, substituting another value we will get here some r q is equal to kt square. So r q is equal to kt square. So r q is equal to kt square. Okay, so we will get here, and rq, so substitutes this value, rq is equal to kt square, t square is equal to rq square. So t square is equal to rq by k. Okay, so now substitute this value r, putting the value of in equation third, first equation, second equations, and the third equations is here. Where is the third equations? Third equations is yes, this is third equations. Substituting this value, substituting this value in equation third, we will get here third equation. Suppose that we are third equation is here, if we substitute this value, f is equal to 4 pi r m r, 4 pi square m r by, here is the 4 pi square m r by t value is given here, k square, sorry, r square by k. Here substitute the values here, and another is remaining here, so 4 pi r square km, it will always be 4 pi square km by r. 4 pi square km by r. R is inverse and r square. These are the equations, and its value will be x. So here is the value we have find out, the f is equal to 4 pi square km by r squares. These are the gravitational force between the sun and the planets that applied here. So with the help of this formula, f is equal to 4 pi square km by r squares applied, and calculates different formulas and different questions associated with the physics. Thank you very much for coming. And once again, I will give you my warm welcomes, so that and I expect that you will certainly subscribe my channel. Okay, thank you, bye bye.